Alright, so now we're going to do our second part, which is division with polynomials. So far we looked at dividing a polynomial and a monomial, so now we're going to look what happens when you divide a pair of polynomials. So why am I showing you long division with a 6 and 126? Good question. Well, if you guessed it or you may not have guessed it, we're going to use long division to divide a pair of polynomials. Now, we worked with long division before. This was even one of the math review concepts from way back in the day. So hopefully you're comfortable with long division. If you're not, good time to get comfortable with it because you are going to need it in order to divide the polynomials. So first of all, a few terms for you. Whenever you have long division, the different players have different names to them. For example, if we're dividing 6 into 126 or 126 divided by 6, the 6 in this case, which is being divided into the 126, is called a divisor. So that is the divisor. The divisor goes outside of the long division bracket. The dividend is what we are dividing into. In this case, the dividend is the 126. The quotient is the answer. So you divide the divisor into the dividend and you get a quotient, which I misspelled. Quotient. There we go. So the players are all here. Let's do our long division. So I'm dividing 6 into 126. First of all, and I already worked it out for you, but first of all, you figure out how many times can this 6 go into the 12? Because I don't know off the top of my head how many times the 6 goes into 126. Pretend that's not done. So we know that 6 goes into 12 twice, so I write a 2 here. 2 times 6 is 12. Over here is a subtraction. 12 minus 12, that's a 0. That's gone. So all that's left is a 6. The 6 just comes down. And now I have to figure out how many times does a 6 go into the 6? Once. So I write that 1 here. 1 times 6 equals 6. 6 minus 6, again a subtraction here. 0. No remainder, because I designed this problem to have no remainder. But that's how long division works. You slowly start putting the divisor into the dividend, because usually you don't know off the top of your head how many times it'll go in there, because then it wouldn't be long division. So you slowly put it in and you generate a quotient up here as you slowly fit the divisor into the dividend. And if always there's a remainder, that's your decimal or fraction, but we're not going to worry about that right now. So that's long division. Again, hopefully you're comfortable with it. I'm not going to spend too much more time with just the basic long division. We're going to jump right into dividing a pair of polynomials using long division. So here we have a pair of polynomials, really simple ones. That's a really simple trinomial, second degree, x squared plus 2x minus 3. And over there we have a pretty simple binomial, x minus 1. Doesn't really get any simpler than that. So we're going to start off easy. So we're dividing the binomial into the trinomial. So right away you know that that's the divisor, that's the dividend, and our answer is going to be the quotient. So that's going to be the divisor, that's going to be the dividend, and the answer is the quotient. So I'm going to set up my long division. Alright, so once again I have my divisor on the outside. That's my divisor. I have my dividend on the inside. That's my dividend. If I can spell correctly. And my answer, which I don't have yet, which we'll generate together, or I'll generate it and you'll listen, is the quotient. So we're going to go through the same steps as we did with the long division for the 6 and 126. So I don't know off the top of my head how many times the x minus 1 is going to go into that. So let's go a little bit at a time. We're going to take the first two terms and figure out how many times will this fit into here. Well, how about I try x, because I know that's a second power, that's a first power, and how do I make a first power monomial into a second power monomial? I gotta bump up its power exponent, and if I multiply an x by an x, I want to get an x squared. Cool. So that's going to be my first part of the answer. So now x times x is x squared, x times negative 1 is a negative x. That's not so bad. So now I'm going to do my subtraction just like always. X squared minus x squared, that's gone. 0. I'm not going to write it there though. Or I can write it there. 2x minus a negative x, that's technically minus minus, which makes it a plus, gives us a positive 3x. Again, 2x minus a negative x, positive 3x. Alright, so that's what's left. Good. This 3 just comes down, just because it does. So now we have 3x minus 3. Alright, so how many times does this go in there? First degree monomial. So I know I'm not going to be multiplying it by a variable now. So that's a 3, that's a 1, 3, 1. Hey, how about a 3? So plus 3 here. Multiplying 3 times x gives us 3x. Multiplying 3 times negative 1 gives us a negative 3. Yay. When we do our subtraction, everything cancels out. We're left with a 0. And that's our answer. X plus 3. Congratulations, you divided a pair of polynomials. Good job. So, it looks pretty simple. Yes, it does. So let's do another. Alright, so here we again have a pretty simple division of a trinomial and a binomial. Nothing too tricky about this, just like last time. The binomial is super simple. The trinomial is super simple too. Second degree, first degree. Except they're both out of standard form. And just like with anything else when we work with polynomials, put them in standard form first. Very much so for division. It's very important. So I'm going to rewrite these in standard form. The second degree monomial goes first, then the first degree monomial, and our 0 degree monomial, the constant, goes last here. And here the first degree monomial goes first, and the 0 degree monomial goes last. That's it. That was the only trick to that particular problem. Then we're going to set up our long division with the divisor on the outside and the dividend on the inside. And now we're going to go ahead and do our division. So I'm going to try to get this into this. Second power, first power. Got to make this into a first power. So how do I get a y to the first power into a y to the second power? Well, maybe I can multiply everything by a y. Just the y, just the one y, because 1, 1, the coefficients are just 1, so I don't have to worry about coefficients here. So y times y gives us y squared. Y times 2 gives us a positive 2y. Good so far. Let's subtract. Y squared minus y squared is a 0. 5y minus 2y is a 3y. And the 4 just comes down. It's a plus 4. So now, ignoring the 0, we have 3y plus 4. First degree, first degree. Terrific. So what do? Well, let's multiply it by a 3. Why a 3? Because the coefficient here is a 1, the coefficient here is a 3. So if I multiply it all by a 3, I will get 3 times y is 3y. 3 times 2 is 6. So here we're actually going to end up with a remainder, which is fine. So 3y minus 3y gives us a 0. 4 minus 6 gives us a negative 2. So we have this negative 2 as a remainder. Oh well, there's nothing else we can do here because there's no way you're going to be able to fit a y plus 2 into a negative 2. Impossible. So the remainder is just going to be written as a fraction. So plus a negative 2 over y2. I actually didn't expect this problem to have a remainder, but that's fine. We're going to run into one sooner rather than later. So now you know how to deal with it. So y for here, 3 for here, and then the remainder, because we have a negative 2 that can't go into the y plus 2, so you just write the negative 2 over the y plus 2 as your remainder, and that is the answer. So let's do another example. Alright, so looking at this problem now, I have what looks to be a binomial being divided by another binomial. Okay, first thing that you should notice, And if you want to tell me what it is right now that I should do to this problem before I can move on, it's your cue to chime in. Yes, you're all correct. They're both out of standard form, so we have to rewrite them in standard form. Good job, class. So the second degree monomial goes first. The 0 degree monomial goes next. Divided by here, the first degree monomial goes first, minus 1. Done. Now I'm going to divide these two out. So the divisor goes first. The dividend goes next. And I didn't leave me much space there. Oh well, we'll work with it. Now, pay attention here. I have second degree, first degree, no first degree in this polynomial. That usually doesn't present a problem, but it doesn't division because we need the same kind of degree players or else problems kind of don't work out so well. So what I can do is I can write down plus a 0m because 0 times m is 0, doesn't really do anything. So it acts as a placeholder so that, you know, we don't have this like missing space. It's going to help the problem look a little bit cleaner, and it's going to make more sense in just a little bit. So now I want to fit this into right over here, not into there, but right into here. So how do I do that? Well, easy. Here we have m to the first degree, m to the second degree. So I got to bump up the power of the m here. Also the coefficients, 2 and 4. So I need to go from a 2 to a 4. So that's easy. If I multiply this by 2, that'll be accomplished. And if I multiply this by an m, it'll turn to a square. So I'm going to multiply everything by a 2m. Alright, so 2m times 2m, that's 4m squared. Exactly what I want. 2m times negative 1, that's a negative 2m. Alright, let's do our subtraction. 4m squared minus 4m squared, well, that's gone, 0. 0m minus 2m, that's just a negative 2m. Remember, that was just a placeholder, so it didn't really do anything. And the 13 just comes down, plus 13. Alright, so looking at this now, 2m, negative 2m, but the values are the same. So I don't actually have to do anything. I want this in here. So I'm just going to multiply it by a 1, plus 1. So 1 times 2m, that's a positive 2m. 1 times negative 1, that's just a negative 1. Everything multiplied by 1 doesn't really change. So let's see what we have here. That's gone. And here we have a 13 and a negative 1, which is going to give us 13 minus a negative 1 is going to give us positive 14. And actually, that should have been a positive 2m now that I think about it. That's why my math isn't working out. Minus, minus, turn this into a positive. So when you subtract, that's why it's a 0. I was actually going to wonder about that. So over here, when we did our initial subtraction, it should have been 0m minus a negative 2m. Minus and minus gives us a positive 2m, so that's why 2m minus 2m is a 0 here. 13 minus a negative 1, so that's minus minus, which is a positive 1, gives us 14. So there's no way you're going to be able to fit the 14 into the 2m minus 1, so that's our remainder. So plus 14 over 2m minus 1. So that's essentially all the different types of polynomial divisions you will encounter. You're going to be doing some examples on the board in just a little bit, and I'm going to give you some time to do the homework, and then you guys are going to jump into the workbooks, which I will check on Friday. So I'll see you guys back on Friday. Thank you.